My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 648. In this lecture, we will try to understand GRUs, gated recurrent unit. Remember, your LSTMs were created in 1997. So GRUs are modern and simplified version, and GRU stands for gated recurrent unit. GRUs are created in 2014. In a nutshell, the structure of GRU that we will see in a little while are very similar to LSTMs. LSTMs have three gates. You have input gate, you have an output gate, and you have forget gate. GRU is basically much more simplified version, which is inspired, I can say, which is inspired, obviously inspired from LSTMs, because these are simplified. I can say these are simplified versions. They are faster to, which one is faster? GRUs. They are faster to train because there are fewer parameters. It is much faster. It is almost as powerful as your LSTM. So in a lot of real world problems, people are tried both LSTM and GRUs. People are tried both. In some cases, LSTMs perform better, and in some cases, GRUs perform better. But most often, GRUs are faster to train. There is no clear, I can say, there is no clear winner on. There is no clear winner on who is better. But if you want more optimized and simpler form of LSTM, GRUs are thin to try, isn't it? In GRU, instead of 3 gates, I have only 2 gates. They have reset gate and update gate. We will see the structure of GRU. So if you look at the core structure, look at the just look at the core structure. Core structure is very simple. So the concept is very simple. Here it is LSTM, which is created in 1997. GRU is created in 2014. Instead of these many equations in LSTM, here in GRU you have far few equations. It is faster as it has got less equation. It has got less equation or few equations. It is faster to compute your back propagation. It is faster to compute back propagation because you have fewer derivatives to compute, isn't it? The structure is slightly different here. You have 3 inputs. Just observe in LSTMs. If you observe in LSTMs, you have 3 inputs, isn't it? What are they? CT-1, HT-1, XT. Whereas in the case of GRUs, you have 2 inputs, isn't it? HT-1 and XT, and you have only 1 output. In the case of GRU, what is that output? HT. Here in GRU, a unit called, just see, there is a unit called 1 minus. The rest of all the units are self-explanatory. We have seen point-wise multiplication. Just see, we already discussed this particular part. Point-wise, what is this? This is point-wise multiplication. This is point-wise addition, isn't it? Whatever you are getting here, just see ZT. Here, let me assume here you are getting ZT. What your is 1 minus means what? Whatever you are getting ZT, that here just you are subtracting from 1. 1 means what? That is 1 minus ZT. 1 minus. There is a unit called at 1 minus. Here you are getting ZT. Therefore, it will be treated as 1 minus ZT. What does it mean? You can you can see the similar structure. You can see the similar structure in GRU, just like, just see there is a similarity between GRU and just see this part, there is a similarity in between LSTMs and GRU, isn't it? You can see the similar structure in this case. You are saying similar structure like this, isn't it? Just try to observe that particular part. You can see the similar structure in GRU. If you don't have this, if you don't have this particular structure, which structure? If you don't have this particular structure, you don't have long term dependencies. Why? Because you can short circuit it through that particular structure only. We discussed it in elaborate manner. If you have all ones here, what happens if you are in pointwise multiplication? If you have all ones, and if you have all zeros at pointwise addition, then what is this? Then you are literally short circuiting. What does it mean? You are literally short circuiting, isn't it? This is I can say this is your output gate, and this is your, what is this? This is your reset structure. The first one is, this is your output structure, this is your reset structure, isn't it? What is reset structure? What is the meaning of this particular structure? What you are decide here is how much your input is reset. This is like a reset, isn't it? There are two gates. There is a reset gate and update gate, isn't it? This is how much, just see what is this? This is how much you reset. That is important. How much you reset here, and this is basically how much you update, isn't it? This GRU is much simpler form, fewer equations, and hence faster computation, faster in terms of computing derivatives. There is also just see, this is much simpler form because fewer equation, and hence it is faster. GRUs are faster. There is also very nice blog here. Just see this blog in towards datascience.com. There is also very nice blog that I came across with slightly different notation. That's why I did not go through this blog. I didn't go through this blog explicitly. I wanted, they are using different notation. That's why I didn't read it properly. I wanted to continue in this same representation that we have seen for LSTM. So actually, if someone is interested, I strongly request you to go through this particular blog also, but their notation is little bit different from our notation. I strongly recommend you to read this blog, but I'm not following this particular notation. We will follow in next lectures also. We will follow the notation which we discussed till now, but we will not follow the notation which they used in towards datascience.com. If someone is interested, just go through this. I can say GRUs in a nutshell. GRUs are basically simplified version inspired by LSTMs, where you don't need to worry about cell state. It all taken care in your outputs and inputs. Faster GRUs are faster to train because you have fewer equations. It is powerful. Your GRUs are powerful as LSTMs, and there is no clear winner, as we discussed. Actually, more recently, more and more people are using GRUs because they are able to train faster and they are able to train deeper RNNs. Remember, till now what we have seen is just single layer on RNN. Everything that we have seen is just single layer RNN. We will see deeper RNNs in my next lecture. If you have any difficulty, please keep a comment. Thank you very much.